Conic sections are another time where it's really helpful to use Desmos. One of the biggest difficulties with graphing algebraic equations, conic sections or otherwise, is connecting an equation to the graph. So even if a question is not asking me what the graph looks like, one of the things I always stress to my students is just graph it. Once you start noticing what the equation looks like, it helps you cement an understanding in your mind of the shapes. So in this video, we're going to cover circles. And so what you need to know about circles is circles are equations that have x squared plus y squared. They can't have any division in them. They can't have any, they can't be solved for y. If you do, you have to have two y equations and it gets kind of tricky. But generally, if I have x squared plus y squared equals some number, that's going to be a circle. And so what I want to do is just kind of show you how things move with circles. So you have your x squared and your y squared, which is centered at the origin at 0, 0. And the square root of the number on the other side of the equal sign tells you about the radius. So here, my radius is 5 units, which you notice if I go from the center of my circle at 0, 0 over to here at 5, that's the radius of my circle. If I change the radius to say 16, the square root of 16 is 4, and so now from the center to the outer edge of my circle is 4 units. So when I'm moving the equation, as I mess with the numbers on the other side of the equal sign, I'm kind of enlarging or shrinking a circle. Now, the circle where it equals 1, we call the unit circle because it has exactly a radius of 1, which is 1 unit. Now, circles can also shift. Just like any other algebraic equation, actually let me make this 16, I can shift a circle. So let's say, what happens here? I did x minus 2. And what I'm going to do is I'm actually going to graph the original equation at the same time, because I think when we do shifts, it's a lot easier if you can see them side by side. So my blue is my original circle, which is centered at 0, 0, and the radius is at 4. And if you look at what I did in the red circle, it's been shifted. So instead of the circle being at -4, it's now at -2. And so if I look at the distance between there, -4 is 2 units away from -2. And I moved it 2 units to the right-hand side. So let's see if that holds true if I subtract a different number. So let's subtract 3 now. If I subtract 3, my new circle is at -1, 0, and my existing circle is at -4. So these are 3 units apart, and specifically 3 units to the right. So at this point, we can make the conjecture that if I subtract a number, it's going to move it to the right by that number of units. Let's test that theory and do addition. So now if I add something, I'm going from, again, my original equation at -4, and now in my new equation, I'm at -7. So they are 3 units apart, and specifically 3 units to the left. And so now I have a good understanding of how to manipulate that x variable and shift my graph. Now let's see what happens with y. Let's do the exact same thing, but with our y variable. So I'm going to start with y minus 1. My red circle is my new circle. My old circle is my blue one. So here I have at my original circle, my y value was -1. Here, my new value is at -3. So if I'm thinking about what I'm doing here, I'm shifting my circle and I'm shifting it around. Oops, there we go. I subtracted 1 from y and it basically shifted it up. This is not what we typically see. We typically don't move up when we subtract from y. So this is one of the ways that conic sections differ from other types of algebraic equations, because it does move opposite with the x and the y. So if I were to subtract 2, you would notice it was like I moved my circle up by 2. And if I change that to a plus, it's like I moved my circle down 2. And so this is something that's going to be specific to the conic section, because again, when I would add or subtract 2 to a regular algebraic equation, it would move in the same direction. And so that is a little bit about circles and how you can work with circle equations. I definitely encourage you to always graph anything that you touch when you're solving, because the visual connection is going to be made a lot stronger from a learning perspective if you are taking that extra minute to just see what it looks like as a visual and not just try to memorize a rule that corresponds to an equation.